All right, let's talk about this worksheet A that you did on what is an atom. Probably before you have talked about protons, neutrons, electrons in the atom, and so this should be a review of maybe 8th grade physical science, or also this is usually covered in biology. So let's take a look at what we should have here for our answers. So you can look at your pictures and see how they compare to mine. Again, we were recreating the images that were on the screen in the phet simulation, build an atom. And so these are the numbers we should have gotten. You were told that the mass number, where you can find that, is up here on the upper left-hand side of the element symbol. So that's where I got those numbers from for there. Notice the mass number is different from the atomic mass. So that's going to be something that comes up in our questions a little bit later on. Also, normally, if there's no charge, if the atom is neutral, normally we won't be writing these zeros up here. This simulation shows us those, but normally we would see it like this if it's neutral. And if there's a charge, then it'll be written like this. A lot of times charges, if it's -1 or +1, you actually might only see a plus sign or a minus sign instead of the 1. And then if it's greater than that, so if it's +2 or -2, then you'll start seeing the numbers written in. So usually you'll just see, again, just a positive or negative here. All right, so looking at these pictures for carbon, again, you compare your diagrams to mine. Notice that all of the protons and neutrons, as it showed in the simulation, those went in the nucleus, and the electrons are going into the energy levels around it. And notice that the first energy level actually only takes up to 2 electrons, and we'll talk about that later on in this unit. But there's only 2 electrons in the first one, and then it can take the rest of them in these pictures in the outermost energy level. So here's what you should have for oxygen, and notice that with the 10 electrons has the -2 charge. Here for lithium, notice I wrote that with just the plus sign instead of a +1, as I mentioned before. And let's take a look at then our critical thinking question. So notice that for each of the carbons, the thing they have in common is the number of protons. So number of protons is what identifies something as whatever the element is. So all carbon atoms are always going to have 6 protons. All hydrogen atoms are always going to have 1 proton. And again, that can be found using the atomic number on the periodic table, which is the whole number on the periodic table. So obviously then you can see when we get to question 6 here, about the atomic number Z. That's what that's getting at. So to identify nickel, again, if I look at the periodic table, I'm going to see 28 as the atomic number. That's indicating the number of protons, and that is unique to all nickel atoms. So that's what you should have for that one. The charges, again, come from the canceling out or the not canceling out of the protons and electrons. So we know that protons have a positive charge. We're going to say that they're +1. Electrons have a negative charge, and we'll refer to them as -1 charge. So protons and electrons have equal magnitude charges, but just opposite signs. So protons are positive, electrons are negative. So if we have equal amounts of protons and electrons, the atom's neutral. So that's what you can see from 8b right here. When protons outnumber the electrons, since protons are positive, that would mean that we have an overall positive charge. When protons, there's fewer protons than electrons, the atom is going to be negative, and we call that an ion. If it's charged, positive ion or a negative ion is a charged atom. And so to figure out the charge, basically what you can do is take the number of protons minus electrons. And this way, if the electrons outnumber the protons, this will end up being a negative number and therefore a negative charge. If the protons outnumber the electrons, then that would end up being positive and therefore a positive charge. If you're writing the charge on an ion in the upper right hand side of the symbol, you should make sure you indicate if it's positive or negative. So don't just assume. Normally we don't write plus signs in front of positive numbers. We only write negative signs in front of negative numbers. But when we're talking about charges, we want to make sure we put in the plus sign just to be clear that we're talking about a positive charge and what that means. Notice the structural difference between isotopes. So you were actually given this little piece of information back here, and notice there's H with a 1 up in the upper left hand side as the mass number and H with a 2. Those are isotopes. So We've already established that to be hydrogen, I have to have 1 proton. To be carbon, I have to have 6 protons. So the difference between these numbers comes from those numbers of neutrons. And so that's what this portion is getting at here. If we take a look at the simulation again, notice that number of protons, that number is 1 here, and that's actually, if there's an extra number on the left-hand side, lower left-hand side of the symbol, that's actually giving us the number of protons. Notice if I throw in a neutron, this number is the one that goes up. This number down here stays the same. So this is the protons. This is the protons plus neutrons. So that's the mass coming from, or the number of particles coming from the nucleus. Notice if I added another neutron, that number goes up further, take them away, and so forth. If I were to add another proton, notice then that makes this a whole other element. So this is now helium, because now we've got a different number of protons, and 2 protons is helium. Mass number is the 2 protons plus the 1 neutron. If I throw in an extra neutron, again, if there's 2 protons, it's still helium, but the 4 means that there's 2 protons, 2 neutrons. Again, I can add another one, see that change reflected up here. So going back to our worksheet, so the mass number, that symbol in the upper left-hand side of the diagram, that is the protons plus neutrons. And if I wanted to figure out what the mass number is, again, for these things that I built, these atoms that I built, I could add up the protons and neutrons, and that should give me this number up here on the left-hand side, upper left-hand side. Most of the mass of the atom is in the nucleus, and how I know that is, well, notice this atomic mass in comparison to the mass number. Now, these are not exactly the same. We're going to get into where these atomic masses come from, how they're calculated, but basically the majority of the mass of the atom is protons and neutrons. Those are both around 1 AMU apiece. Electrons are about 1/2000th the mass of a proton and a neutron, and so they're not really contributing much to the mass. So the mass number is basically the count of the particles in the nucleus, and those particles are the ones that give us the majority of the mass of the atom. So the mass number is going to be close to the average atomic mass, but it's not going to be exactly spot on because this is a more precise number. And when we talk about the masses reported in the periodic table, because of these different isotopes, because of the different, I can have oxygen 16, I can have oxygen 15 maybe, or oxygen 17, because of the different isotopes and the different massed atoms of oxygen, that will be reported as an average, and we'll get into how that happens later on. So here is the exercise you should have completed. So notice I can always look up the atomic number on the periodic table if I know the symbol of the element. In this case, since the symbol was missing, they gave that to me, so I knew that it was potassium, and then from there I could figure out everything else. This actually should be a +1 charge, actually, on the potassium, now that I am looking at that. Let's see here. Scroll down. So mass number we've said is protons plus neutrons in an atom. Atomic number is the number of protons in an atom. And can take a look at question 4 here. The following statement is false. So protons and electrons are equal, but the neutrons are not. And again, you can figure that out because we know there's 8 protons because it's oxygen. 18 minus the 8 would give me 10. That tells me how many neutrons there are. So those are not equal. Because it's neutral, there are equal number of electrons, though. To take a look at these answers down here for number 5 and 6, and pause the video if you need to take a closer look at the numbers. But again, all the protons I can tell from the type of element that I have. So anytime I've got 2 of the same element, so chlorine always has 17 protons. Neutrons, again, I'm going to get by taking this mass number minus the number of protons, and that's the neutrons, since P plus N gives me the 35. The electrons, so notice if it's neutral, so there's no charge, electrons are equal to protons. We see that with the magnesium as well. With the positive charge, that means I've got 1 more proton than electron. Proton numbers do not ever change. So this is sodium, it's got 11 protons. That means that in order to get my +1 charge, it has to be 1 fewer electron than protons. If I have a negative charge, that means I must have more electrons. So in the case of chlorine here, notice that I've got 18 electrons, so that's 1 more electron than proton. That's what gives me the -1 charge. if I'm dealing with a positive 3 charge or a -2 charge, right? So more than +1 or -1, we'll notice that's the number difference in protons. So 3 more protons, so I've got 26 protons because it's iron, and then notice that this is 23 electrons because that's 3 fewer of the negative particle, thus giving me an overall positive 3 charge with 3 more protons and electrons. And again, that formula that I wrote out in one of the previous questions shows me how I could figure that number out. I could work from there. And check out your answers to the table here. And then, again, isotopes, we're going to be investigating this, but what they have in common is they have the same number of protons. They have different numbers of neutrons, though, and therefore different mass numbers, and therefore different masses. And we will get into then how do we know how do we report the masses that are on the periodic table if we've got different masses of isotopes. But basically, if you want to know the number of neutrons in an atom, you're going to have to be told the mass number in order to figure that out. So there's no way to figure that out from the periodic table. All right, so this is worksheet A. We're going to be talking about all this stuff in class. So go back through and feel free to read through anything that I rushed through, but we will talk about all of this in class the next time.